All right, everybody. Welcome back to week 3 of quarantine chemistry. We're going to focus on gas laws today. So I would suggest get your study guide or your learning plan, maybe even a piece of notebook paper, and jot these down as we go to kind of summarize everything. The PowerPoint for this, the slides, will be attached to this document as well, so you can go back and look through those. The first gas law that we're going to focus on is going to be Boyle's law. And Boyle's law states that pressure and volume are inversely proportional. This symbol right here, this little fish looking symbol, stands for proportional. So pressure and volume are inverse only when temperature and amount are constant. One thing I want you to notice, the two things that are related in Boyle's law, pressure and volume, they have variables in the equation. The two things that are constant, temperature and amount, they're absent from the equation. So anything that's not in the equation is going to be constant. So Boyle's law, pressure and volume are inverse with each other when temperature and amount are constant. When the equation is set up so that you have one set of data, one pressure and volume set on one side and the second set on the other, if everything's in line, there's no denominators. If everything's in line, then it is inverse. So that's just a way that you can figure out your relationship from your equation. So remember, inverse variables are in line, no denominators. Directly proportional relationships, this would encompass the majority of the other gas laws we're going to look at. When a gas law equation shows directly proportional relationship, if one set of data is on the left, the other is on the right of the equal sign, the variables will be written as a fraction. So they will be divided by each other. So when you're looking at an equation, direct proportionality, the variables are divided, direct divided. So let's look at Charles' law as an example of that. Charles' law tells us that volume and temperature are directly proportional. So they're in the equation, V and T, when pressure and amount are constant. Notice there's no P and there's no N in the equation. Now, one thing you'll notice in this gas law is that you have two different versions of the equation. There's one with the V's on top and there's another one with the T's on top. It's just to simplify your algebra. If you're trying to solve for a volume, use the one on the left. It'll be easier to isolate V1 or V2 when we get into algebraic rearrangement later on. If you're looking for a temperature, you want to use the one on the right where the T's are on top. The other thing you need to remember with Charles' law, with Gay-Lussac's law, with the combined gas law is you never use Celsius for your calculations. Always, always, always convert Celsius to Kelvin by adding 273 before you plug your values into your calculations. Gay-Lussac, very similar. You can see it almost looks identical to Charles' law, except for instead of V over T, it's P over T. Pressure and temperature are directly proportional when amount and volume are constant. Again, you would use the one on the left if you're trying to find a pressure. Put the P's on top if you're trying to find a P. Put the T's on top if you're trying to find a temperature. So P and T are directly proportional, so they're written divided by each other. They're direct, they're divided by each other. Here's all the relationships. P and V are inverse. P and T are direct, V and T are direct. So if P and V are inverse to each other and direct to T, what would that equation look like? Did you come up with that? This is the combined gas law. It's the last gas law we're going to cover this week. It tells us that pressure and volume are inverse to one another, but they're both directly proportional to temperature. So P and V are in line, but they're both divided by temperature. P and V over T. If you're trying to find a pressure or a volume, you would use the ones on the left here. P1 V1 over T1 equals P2 V2 over T2. Or if you're looking for a temperature, you could do T1 over P1 V1, T2 over P2 V2. Again, picking one or the other, you want what you're looking for on top and by itself. So start with pressure and volume on top if you're looking for pressure or volume. Start with temperature on top if you're looking for a temperature. Now, let's break into the last thing that's testable. We went over the gas laws, their relationships, the statement that goes with them, the equations for each one. You need to know those. But this is the last thing that's testable for this week. You need to be able to look at a problem and figure out, based on what's given, which gas law we need to use. So if we look here, it says the pressure of a gas in a 1,250 milliliter piston. So that's a volume, milliliters is volume. The pressure is 2,500 millimeters of mercury. So this volume and this pressure go together. What would the pressure be? So we're looking for a second pressure if the volume was changed to 750. So we have V1, P1, V2 is our question mark, and 750 is our second volume. So the first thing we're going to want to do is write down what we know. We know an initial pressure, an initial volume. We know the end volume. What we need to find is the end pressure. So which gas law has just pressure and volume? P and V. Oh, that's Boyle's law. P1 V1 equals P2 V2. Think about what we just did. We went through and we looked at the volume, pressure. They asked for another pressure. They gave us a second volume. There's no temperature. There's no amount. So we only have pressures and volumes. What law only has pressure and volume? Boyle's law. Try this one. We have a sample of gas trapped in a container with a constant volume that starts at STP. What's that? STP, standard temperature and pressure. So that's 0 Celsius or 273 Kelvin. And 1 atmosphere, 760 millimeters of mercury, 101.325 kPa. So if you don't remember STP from week 1, go back and review what is STP equal to. 0 Celsius, 273 Kelvin, and 1 atmosphere, or 760 millimeters of mercury, or 101.325 kPa. Temperature changes to 1,000. So it goes from 0 Celsius, 273 Kelvin, to 1,000 Kelvin. What do we have? We have temperature. We have pressure. They gave us a second temperature, and they're asking us for a second pressure. So what do we know? We know the initial pressure, the initial temperature. We know the end temperature. They're asking us for the pressure. What law is pressure and temperature? Gay-Lussac's. In a sample of a gas inflated balloon up to 5.21 liters at 21 Celsius. So there's a volume and a temperature. What will the new volume be? A second volume when the temperature drops to 3 degrees Celsius. So they give us a temperature, a pressure, a temperature and a volume, and another temperature. Initial volume, initial temperature. Always have to change your temperature to Kelvin. Add 273. End temperature was 3 Celsius plus 273 gives you 276 K. They're asking us for this volume. So what gas law has volume and temperature only? No pressure, no amount. See if you can figure it out. Pick Charles. V1 over T1 equals V2 over T2. What about this one? There's a helium balloon, volume 4.88 liters, temperature 22 Celsius, or 295 K. Pressure of 150. Oh, so there's a volume, a temperature, and a pressure in this one. And then what will the volume be at standard temperature and pressure? So this is what they gave us. They gave us an initial volume, an initial temperature, initial pressure. So we got V, T, and P. They gave us a second temperature, a second pressure, and they're asking us for a second volume. So what gas law has temperature, pressure, and volume in it? Combined gas law. P1 V1 over T1 equals P2 V2 over T2. So that's the end of your testable material for this week. What are the gas laws? Boyle's, Charles, Gay-Lussac, and combined. You need to know the statements for them. You need to know their equations. We need to be able to look at a problem or a scenario like one of these that we just went over and figure out what do we have, and then let the data that's given point us towards which gas law we need to use. That's the end of the testable material at this point. So what we're going to do beyond today, you're going to work through the tutorial videos and the problems for each gas law. Boyle's, Charles, and Gay-Lussac, combined gas law, 4 laws between Tuesday, Wednesday, and Thursday. You're going to take the practice assessment. Please take it before you take the graded assessment. Discussion thread for this week is going to be basically Q&A. So if you're stuck on something or you don't understand why I did something, shoot me a question. Send me a picture of the problem you're working on email and ask for some feedback. You're going to take the week 3 assessment. That's going to be due on Monday, May 4th, before midnight, 11:59 p.m. You're going to work through the week 3 practice problems worksheet. Submit that digitally. Instructions are included on the document, and it'll be in the stream on how to do that. That's due Monday, 5/4 by 11:59 p.m. as well. Please shoot me a message and let me know if you have any questions so that I can help you out. Again, for this week, you've got graded wise. You've got the practice assessment. You've got the problem set that you're going to work through and submit by Monday before midnight. And you've got your week 3 test, your assessment. Those are your 3 grades for this week. The practice problems through the week are meant for just that, just practice. Let me know if you need anything.